Why, hello everyone. Just gonna hop right into this thing because why not? This is just a quick little live stream here because we finally have some new renders, new information, a full press release for SpaceX's HLS, the Human Landing System, which is, the human landing system for the Artemis program. So how SpaceX is going to build a lunar lander for the moon. So this is really exciting. We've been waiting since 2021 for any significant updates. This is the most significant update I think we've had in that entire time in 4 years. So instead of me making a video about it and literally just basically rewording the press release and going over everything and then editing it, I figure why don't we just go over this on air? We'll just talk about it all together. Go ahead and ask questions. We'll kind of save them until the end. I'm going to try to keep this nice and succinct and go over all these fun little details and just talk about it. And as you guys probably know, this is likely a response to acting NASA Administrator Sean Duffy's kind of plan or desire to, he's talking about trying to get humans back to the moon in 30 months and trying to do this executive order and reopening up the contracts to allow for other companies to come in here and try to bid basically to do it in 30 months versus the 4 years that we've had already. So yeah. And obviously SpaceX is one of the contractors and Blue Origin is the other one with Blue Moon. But this is the Starship. We have some really, really cool new images and a lot of information to go over. So I'm just going to start going over this information. I'll kind of stop and answer questions and add little details, but there's a lot to get to. So let's just get right at it. Why not? Humanity is at an inflection point. For the first time in our existence, we possess the means, technology, and for the moment, the will to establish a permanent human presence beyond Earth. Starship is designed to make this future a reality and is singularly capable of carrying unparalleled numbers of explorers and the building blocks they'll need to establish the first outposts on lunar and other planetary surfaces. For these reasons and more, it was chosen to fulfill the key role of landing the first astronauts on the moon in more than 50 years. It'll be a central enabler that will fulfill the vision of NASA's Artemis program, which seeks to establish a lasting presence on the lunar surface, not just flags and footprints, and ultimately forge the path to land humans on Mars. So nothing new there, just some fluff about kind of the rah, here's what we're hoping to do. This render we've seen, this might be a small tweak on the renders that we've seen, but just a friendly reminder if you're unfamiliar with this is what they're planning to do, which is absurd. You can see little tiny humans down here for scale, down on the left. You might not even notice them because this thing is 50 meters tall, basically 150 feet tall or so. Absolutely gargantuan, 30 feet wide, 9 meters wide. So much the lunar lander the Apollo lunar lander would be the size of the elevator that's sitting down there at the bottom. This is it's ambitious isn't even the right word. This is a ludicrous idea for a lunar lander, but this is what SpaceX has won a contract for, what they've been working on. So let's keep reading about it and we'll see if we can kind of make more sense of why, what, how, when, etc. With the scale of Starship and the technological breakthroughs, also me reading just live is a nightmare. Technological breakthroughs it's engineered to achieve, SpaceX is moving at a historically rapid pace. Starship provides unmatched capability to explore the moon thanks to its large size and ability to refill propellant in space. One single Starship has a pressurized habitable volume of more than 600 cubic meters. So we've talked in the past, I'm pausing here, we've talked in the past about it being roughly 1,000 cubic meters, based on kind of early, just the size of how big the nose cone and the upper payload section was of Starship compared to its tankage. This has always kind of been likely to change. 1,000 cubic meters is more internal volume than an entire 747. So I think we can easily cut that in half and still have too much internal volume, just objectively still way too much. I mean, what was the Apollo LEM? I don't know if I'm not probably going to pull it up here right now, but the Apollo LEM was I don't remember, definitely not 100. I think it was only 15 or 20 cubic meters or something. I can't recall off the top of my head. Maybe Discord, you guys can help me find that, but it's a small number. Oh yeah. And there is a lunar lander here for scale. That I might pull up later. So let's keep going with this though. So it's roughly 2/3 the pressurized volume of the entire International Space Station. There we go. That's a good comparison. And it's complete with a cabin that can be scaled for large numbers of explorers and dual airlocks for surface exploration. I think we've heard about that before, but this is good confirmation. For comparison, each of Starship's 2 airlocks have a habitable volume of approximately 13 cubic meters, which is which is more than double the space that was available in the Apollo LEM, in the Apollo Lunar Lander. Okay, so that's what we're talking about when we're talking about scale. Just the airlocks. Each airlock is, and there's 2 of them, is over twice as big as the entire Apollo Lunar Lander, as far as internal volume. That's the scale we're talking about here. In other words, the entryway to Starship is bigger than the entire thing that landed on the moon and took humans to the moon in the first place. So when we're talking about scale, that's what we're talking about. It's just absolutely beyond anything that's been proposed and that we've seen before. So, yeah. Cargo variants of Starship will be capable of landing up to 100 cubic metric tons directly to the surface, including large payloads like unpressurized rovers, pressurized rovers, nuclear reactors, and lunar habitats. To return Americans to the moon, SpaceX aligned Starship development along 2 paths. Now, this is the important thing. When I was reading this is kind of the part that I think a lot of people might get confused, might not understand, because it's different. SpaceX aligned Starship development along 2 paths. Development of the core Starship system and supporting infrastructure, including production facilities, test facilities, and launch sites, which SpaceX is self-funding, representing over 90% of system costs, and development of the HLS specific Starship configuration, which leverages and modifies the core vehicle compatibility to support NASA's requirement for landing crew and returning them from the moon. SpaceX is working under a fixed price contract with NASA. This is the key thing that a lot of people forget, that a lot of people don't necessarily talk about, that, they might get confused with when they see a Starship test flight blow up and they go, oh, there goes our taxpayer dollars. Not really. And this is why. NASA is working under a fixed price contract with NASA, ensuring that the company is only paid after the successful completion of progress milestones. And American taxpayers are not on the hook for increased SpaceX costs. SpaceX provides significant insight to NASA at every stage of development process along both paths, including access to flight data and missions not funded under the HLS contract. So in other words, they're sharing their findings from these, flight 1 through 11 with NASA, kind of in good faith to help them understand and get value out of even those test flights, even though those test flights are arguably most valuable for SpaceX. Both pathways are necessary and made possible by SpaceX's substantial self-investment to enable the high-rate production, launch, and test of Starship for missions to the moon and other purposes. Starship will bring the United States back to the moon before any other nation, and it will enable sustainable lunar operations by being fully and rapidly reusable, cost-effective, and capable of high-frequency lunar missions with more than 100 tons of cargo capacity. So, yeah, that's a bold statement that SpaceX will bring the United States back to the moon before any other nation, and it will enable. So they're still talking the talk, like they're going to beat Blue Origin with their, Blue Moon architecture, which is by all means, it's still ambitious. It still requires refueling. It still requires a lunar tug, but it's a lot more manageable scale. It's a lot more normal, still like way bigger than, the Apollo program's lunar lander, and way more capable in that sense as far as down mass and as far as habitable volume. However, it's a lot more feasible, right? Or I guess scale-wise more feasible. So those are some strong words to still believe that they're really in the fight, even though they haven't made it to orbit yet with Starship. So that's where this is getting interesting. So that's kind of what this next section is about. And obviously we see a beautiful picture from one of the re-entries of Flight 11 there from S-38. Since Starship Flight 1 in April 2023, which we all remember, SpaceX has rapidly advanced vehicle development through an active flight test campaign. In line with past vehicles development, SpaceX maximizes real-world testing throughout this process to quickly and safely demonstrate capabilities, identify areas for improvement, and prove out solutions. This campaign has quickly matured the core Starship matured the core Starship and has produced numerous feats, including multiple successful ascents of the world's most powerful rocket, the launch, return, catch, and reuse of that rocket to unlock the high launch cadence needed for lunar missions, the transfer of approximately 5 metric tons of cryogenic propellant between tanks while in space, a first-of-its-kind operation that provides key data for future full-scale propellant transfer operations, successful in-space relights of Raptor engines that are critical for the maneuvers that will send Starship to the moon, and multiple controlled reentries through Earth's atmosphere. This is all just review of basically where we're at in the last, however many years since this has been flying. So, this should be no surprise to anybody. The one thing that is, I think we knew this, but it's just fun to remember that they did already they've done a propellant transfer demonstration of 5 metric tons of propellant. That's a lot. That's a very good amount of propellant. That's more mass than a lot of vehicles can even take to orbit, period, let alone just have like a spare propellant to slosh around and move from one tank to another. So they've already demonstrated that, which is a good sign leading up to some more stuff that we'll talk about. And so let's keep going here. To date, SpaceX has produced more than 36 Starships and 600 Raptor rocket engines with more than 226,000 seconds of runtime on the Raptor 2 engine, and more than 40,000 seconds of runtime on the next generation SpaceX or Raptor 3 engine. There have been 11 Starship-only flight tests and 11 Starship-only flight tests. Where are they getting that from? Are they Starship-only tests? I wonder if they're talking about Hopper and SN 5 and 6 and then 5. Kind of. By that count, I count 10. I don't know. Anyway, it doesn't matter. 11 Starship-only flight tests and 11 integrated flight tests of Starship and Super Heavy. In parallel, SpaceX has constructed and continues to construct new Starship launch, production, integration, and test facilities in Texas, Florida, and California. This private investment of billions of dollars is creating more than 5 million square feet of manufacturing integration space, 5 launch pads across Texas and Florida, and multiple Raptor test stands, all engineered to ramp Starship's launch cadence above and beyond the paradigm redefining rate achieved by SpaceX's Falcon program. So, yeah, kind of review still, but here's where things get really interesting, and here's where I want to start pointing out some things. First off, this image is not a render. This image is hardware. You can tell there's paint. There's you can just tell. You can just tell there's some renders don't often have these little imperfections like in the the padding and stuff like that. You can see paint discoloration with that hook up on the ceiling. I mean, this is definitely an image of hardware, which is really awesome to see. This appears to be the airlock, which is really cool. I love that there's screens and a little place to put your gloves and a little vent. I mean, I don't know what all this stuff does. I hope we learn more about that, but this is, I'm not sure, but it appears to be some kind of thing that I'm glad they shared. This is what we call a Raptor engine firing. This is a really cool one because this actually shows the interface that the astronauts will have when they're looking, this is literally like in the cockpit. This is what the control surfaces look like, very similar to Dragon, how Dragon doesn't really have a bunch of knobs and dials and doesn't really have joysticks and things like that. It just has a giant touchscreen for its entire control surface. That appears to be where we're at here. And actually, you know what? If we looked at this closely, we do see that it's showing 2 sea-level Raptors still firing. Can't quite tell what the altitude is, but it appears to be, it seems like it'd be relatively close to the ground. So I'm surprised if they'd still be firing sea-level Raptor engines that close to the ground. But, maybe we'll learn more about those details of when they switch over from the Raptor engines to their kind of landing thrusters that are in a ring around the top that we'll talk about a little bit more. This looks like the deep chill-in for the vacuum Raptor engine that we'll talk about in a second. This is the elevator test that they did with the Axiom spacesuits, another milestone that they bring up in this article. And this appears to be just heat shield testing. unless it's something else that we don't know about. But yeah, that's kind of the fun little bits of pictures and things that we see here. So let's keep going with, now this is where we start to see some actual like fun stuff. So this was the most nuanced bit. In parallel to development of the core Starship vehicle, SpaceX's HLS team has completed 49 milestones tied to developing the subsystems, infrastructure, and operations needed to land astronauts on the moon. SpaceX has received money only on contractual milestones that have been successfully completed, the vast majority of which have been achieved on time or ahead of schedule. Highlights of completed milestones include, so these again are highlights, they're not going to go through all 49 milestones. Lunar environmental control and life support and thermal control systems demonstrating using full-scale cabin module inhabited by multiple people to test the capacity to inject oxygen and nitrogen into the cabin environment and accurately manage air distribution and sanitation, along with humidity and thermal control. The test series also measured the acoustic environments inside the cabin. So they are to that point already where not already. I'll say they are to that point where they're developing full-size test beds to be able to do really the entire environmental inside. So acoustically, what you'd be hearing is it going to be a giant echo chamber. Can you breathe oxygen? Is it, humidity, all that stuff. So that's life support 101. Glad to see it's been tested. And that they're to the full scale. That's the key there, is that they're not just doing little subscale stuff, but they're doing full-scale cabin modules. Awesome. Docking adapter qualification of the docking system that will link Starship and Orion in space, an androgynous SpaceX docking system capable of serving as the active system or passive system and based on the flight-proven Dragon 2 active docking system. So that's awesome. Androgynous means that it can be basically male or female, and it can work with the IDA, the International Docking Adapter on Orion. It's great that they have the qualification done for that, because docking to Orion is a requirement. And by the way, I should mention that I've been working, so you may notice that there's a ton of content coming out all of a sudden like this week. It's because I've been working on contract stuff. We finally completed a video with Space Force that I'm really excited about. Watch it. It's all about the range. It was a way bigger project than I ever envisioned. But meanwhile, I was also working on this, which is like hundreds of lines of delta V charts and equations for the Artemis program, trying to figure out, like, are there other options? So that's something that you can look forward to. Hopefully having that out by the end of the year. It is a 20-page script, so that's an hour-long video, and I don't know how quick, like an hour. Hopefully by the end of the year. That's my goal. So we'll be talking about that kind of stuff, like docking to Orion, why that's necessary, why that's when they'll continue to do that, et cetera, et cetera, et cetera. So just as a little teaser of things to come. Just so you know, I haven't been just doing nothing for the past 3 months. It's actually just been a billion things lining up at once, as they always do. That's just my life. So landing leg drop test at full-scale article at Flight Energies onto simulated lunar regolith to verify system performance and to study foot to regolith interaction. That is awesome. That's a really big one. People see Starship as it is now, and SpaceX has even talked about just landing on Mars with no landing legs for the first ones. But obviously people look, and say, well, Starship doesn't even have landing legs. It's like, which version of Starship are you talking about? Are you talking about the orbital version for Earth, for Leo? The tankers? No, they don't need landing legs. They can be caught. On the moon, you're going to need landing legs. And they're working on landing legs. And hopefully those are actually going to be self-leveling. It's another thing that was talked about. They don't mention that here, but the fact that they're at least doing full scale with full energies, which is fun because it's only even though it's hundreds of tons of vehicle mass on the surface because of its propellant and its dry mass, it's only a sixth of that as far as the energy involved because of the 1/6 lunar gravity. So landing legs will still need to be beefier than the Falcon 9s, believe it or not, when you factor that in, because Falcon 9 lands, roughly 20 tons empty. And so if you times that, by 6, you could weigh 120 tons on the moon and still be kind of in the same ballpark there as far as its stresses. So the HLS, though, is hundreds of tons. So it'll be beefier landing legs than what we see on Falcon 9, believe it or not, which those are actually pretty big, beefy legs. So it will be kind of cool to see like substantial legs, even though it's a lunar lander. This is an interesting one that I thought was fun. Raptor landing Raptor lunar landing throttle test demonstrating a representative thrust profile that would allow Starship to land on the lunar surface. So some nuance there is that they're talking about, that allows Starship to land on the lunar surface and using Raptor on a low throttle setting. However, we still believe and we're still expecting that they will use these little thrusters up here that are probably likely a pressure-fed hot gas, not warm gas, but an actual combusted methalox thruster to do the final landing when you're, let's say, twice the vehicle's height or something, just to bring it, like the Raptor could literally get it down to basically 1 meter per second or something really, really, really slow. And then they can just do the final, like basically hover touchdown using basically boil off gas from ullage gas from inside the tanks. But it sounds like they'll still want to be really low throttle as they get near the surface. So you're not shooting lunar regolith around the moon, basically shooting it into orbit and potentially shooting it back at yourself. I don't know the exact velocities there, but it could be bad if you had a full throttle Raptor firing really close to the ground, because that is how you make a big giant crater and or throw lunar regolith everywhere. So I thought that was interesting. Raptor lunar landing throttle test. Oh, when I click on that, what's it go to? Oh, didn't realize this was the descent burn. So this is the throttle. Wow. I don't really have sound going on here, but maybe I could. Maybe there's no sound. But okay, I mean, we've seen a Raptor engine fire before, but that appears to be the vacuum, but that's not a vacuum engine there. That one shot almost looked like it's... Anyway, that's cool. How do I get out of this? Yeah, just because I have this all wonky-do here. Let me go back. Where are we in this? We are here. Okay. Back to this. Okay, so that's cool. Didn't realize that had a video. Nothing too surprising there. Let's keep going here. Micrometeoroid and orbital debris testing of shielding, insulation, and window panels, analyzing different material stack-ups that will be used to protect Starship from impact hazards and harsh thermal conditions. That's cool. That's something that people talk about a lot, is, for these long-duration missions. What keeps micrometeorite from, punching a giant hole in the tank and the whole entire mission is done? So that's really cool to see they are studying that and working on that. Next one's a big one, obviously landing software, sensor, and radar demonstrations, testing navigation and sensing hardware and software that will be used by Starship to locate and safely descend to a precise landing site on the moon. Software architecture review to define the schematic of a major vehicle control process, what physical computers they will run on, and software functions for critical systems like fault detection, caution and warning alerts, and command and telemetry control. Raptor cold start demonstration. So this is what we were showing that picture of. We're using both sea level and vacuum optimized Raptor engines that are pre-chilled prior to startup to simulate the thermal conditions experienced after an extended time and space. That's important. This is beyond just a chilling. This is like a deep chill. It's almost probably beyond what you'd normally do if you're chilling the engine down for on ascent or on the launch pad. Because the biggest thing is, as you spin up these pumps with cryogenic propellant in them, if you have if you don't thermally condition the pumps for cryogenic temperatures, they can crack and you can have too high of stresses. It's not the heat that you're necessarily needed to thermally condition the engine for. It's actually the cold. But this will be extreme because they'll be sitting there coasting for days, basically tucked up against cryogenic propellant tanks. So they'll be deep chilled. And that's what they're talking about here is Raptor cold start demonstration. So thermal conditions experienced after an extended time and space. So that'll be really interesting. Integrated Lunar Mission Operations Plan Review, covering how SpaceX and NASA will conduct integrated operations, develop flight rules and crew procedures, and the high-level mission operation plan. So that's basically, how do we work with NASA to say who is in charge of what, when they dock, who's doing what, when, where, how, and why, who's in control of probably the docking procedures, and what's our, what are our boundaries, all those rules that you need to be able to develop in order to safely handle a mission like this. Let's see. Depot power module demonstration. Testing prototype electrical power generation and distribution system planned to be used on the propellant depot variant of Starship. That's really cool. So yeah, there will be a power generation for the propellant depot. So basically, I'm guessing that's them talking about needing to be able to keep the cryogenic propellant at a cryogenic state. So keeping boil-off mitigation systems. So you can basically, ironically, you can actually use a little bit of the propellant on board to be able to run like a generator to continue to cool down the propellant. That's one way. You know, we've seen how Blue Origin's working towards a giant shield, a sun shield, and it has on one side of it is solar panels, and then it has a giant, like, I don't even remember what it was, like 40 meter diameter or something crazy huge solar shield to prevent boil off. And then they'll be using that energy to keep the propellant on board. The hydrogen, which is even harder to keep from boiling off. So that's something that you do have to do when you're dealing with these depots and things like that. The next thing, ground segment and radio frequency communication demonstrations, testing and the capability to send and receive RF communications between flight equivalent ground station and flight equivalent vehicle RF systems. Okay, that's obviously important. Elevator and airlock demonstration, which was conducted in concert with Axiom to utilize flight representative pressurized EVA suits to practice full operations of the crew elevator, which will be used to transfer crew and cargo between Starship and the lunar surface. That's awesome. Like we showed in that one render, this is a large vehicle and it has to have its own elevator to get from, like 40 some meters up, over 120 feet up in the air down to the lunar surface. It's very different than the little lunar lander that the Apollo LEM had. I've always wondered if there's going to be some kind of backup, like are they going to put little tiny, handholds as a way to be able to climb back up in 1/6 gravity? That'd be relatively easy as far as the physical strength to be able to climb that high. But it still would be a consideration. And I don't know what the backup is if the elevator gets jammed. And I'm sure that's something that people are considering and talking about and trying to figure out. And maybe even part of this elevator and airlock demonstration. Medical system demonstration covering the crew medical system on Starship and the telemedicine capability between ground and crew. That's really cool. I didn't even think about that. Hardware in the loop testbed activation for the propellant transfer flight test, which uses a testbed with flight representative hardware to run simulations for the upcoming propellant transfer flight test. Okay, that's not the cool part. There's a little bit that we get to talk about. Meanwhile, though, as we continue to move on here, we get another really cool render of the inside here. And so just for reference here, you see the windows. These look like pretty decent sized windows. They're not huge. They're not audacious, I would say. They're big, but those are way up here near the top of the nose cone. That's what we're looking at here for kind of the flight deck. Then it looks like that's kind of on its own floor. You have this floor, and then it looks like that ladder is what is taking you down into the airlock, and we'll kind of call it the space garage, kind of, is this center. Would be my guess. Now, the thing that's missing in this render, and I think they talk about it and show it in a different render. I love that version. Where is that? Maybe that's just on X. But they showed looking up, and it looks like there's just an absurd amount of empty space above this. You're still looking at the massive taper of the nose cone, which looks like hundreds of cubic meters of volume. So I'm still wondering, where do they sleep? Where's the bathrooms? This looks great and looks fun, but where is all the stuff? Where do you sleep? And yeah, I'll look for that render here after this. So let's keep going here on the next steps. Like I said, this is a really in-depth article. That's why I just figured we'd kind of go over it like this, and hopefully this is valuable for you guys too. While many of SpaceX's remaining HLS contract milestones are tied to flight tests, such as ship-to-ship propellant transfer demonstrations, SpaceX has started fabricating a flight article Starship HLS cabin that will include functional avionics and power systems, crew systems and mechanisms, environmental control and life support systems, cabin and crew communication systems, and a cabin thermal control unit or system. This flight-capable cabin will enable engineers to demonstrate high design maturity of the various systems required to support a human landing on the moon, enable integrated system-level hardware testing, and provide a highly realistic training experience for future lunar explorers. So basically, they're prototyping out and trying to lay out actual, like, real-life hardware for this. Already. I'm not going to say already because it's 4 years in the making. It's not like this is like, wow. But yeah, it's that they are fabricating flight article. So I don't know if that means test flight, if that means uncrewed test flight, or if that's just a flight article version that they'll use just for ground testing, but it's, finished-ish. We've seen this before. I think we saw this on one of the last Starship streams, giving us a decent sense of what the propellant transfer will look like between two starships. We really got to see this next year. And by next year, I mean, what is that, 2026? So I'm really hoping that we see this, in 2026. I think it'd be at least flight like 15, 16. But maybe that could be done by then. But that's what the docking will look like between two starships as they're transferring propellant. And that's what this section of article is about. The next major flight milestone tied specifically to HLS will be a long-duration flight test and the in-space propellant transfer flight test. The exact timing will be driven by how upcoming flight tests debuting the new Starship version 3 architecture progresses. But both sides of these tests are targeted to take place in 2026. On-orbit refueling enables Starship to complete the Artemis lunar mission architecture and carry up to 100 tons directly to the lunar surface, providing the capability to carry rovers, habitats, and other payloads needed to establish a permanent and sustainable presence on the moon. I mean, in fact, if it can truly deliver 100 tons of payload, if it's fully fueled in LEO, that makes sense. That's not that far, that fits within the kind of the Delta V budget of what it can do. It would be about 100 tons to the surface. But what's interesting to think is you basically carry 5 Apollo lunar landers as payload to the lunar surface using this. So just keep that in mind. That's fully loaded, by the way, like with all the propellant. You can carry 20 of the ascent modules, 20 of the Apollo ascent modules as payload and just deliver those to the surface and then just take off from the moon with those. That actually wouldn't be a bad idea. Have some like emergency ascent vehicles. Wonder if anyone's working on that. Business idea. Let's see. So it will start with Starship launch from Starbase to spend an extended time on orbit, gathering data on vehicle propulsion and thermal behavior on an extended duration mission, including long duration propellant storage and boil-off characterization. A second Starship will then launch to rendezvous with the first to demonstrate ship-to-ship propellant transfer in Earth orbit. Starship version 3 vehicles come equipped with docking ports and can be configured to act as tanker vehicles with the addition of docking probes. Starship also has a connection point where propellants are loaded onto the vehicle in preparation for launch that has been updated to enable on-orbit propellant transfer. For rendezvous, Starships will be equipped with Dragon Eye navigation systems, which have extensive flight heritage from their use on SpaceX's Dragon spacecraft during dozens of dockings to the International Space Station. These sensors have undergone separate testings to characterize their performance for use on Starship. SpaceX has also been flying experimental propellant gauging sensors on every recent Starship flight test, which use radio frequencies to accurately measure propellant levels while in microgravity. That was a really cool sentence. Let me read that again. SpaceX has been flying experimental propellant gauging sensors on every recent Starship flight test, which use radio frequency measurements to accurately measure propellant levels while in microgravity. I can't even begin to imagine what that actually involves, but somehow you use radio waves to bounce around inside the tanks and accurate, like maybe with basically like sonar with radio waves, measure how much propellant's in the tanks. Because don't forget when you're in 0G, or they call it microgravity. I hate that term. We'll call it 0G. There's no acceleration. Everything's in the same relative frame of motion. Propellant is just blobbing around. And you don't have it sitting, flush with the tanks. So therefore you can't, you can't measure it in a cup and be like, yeah, this is how much it is. Cause it'd just be, So how do you measure it? How do you actually know, factually how much you have? So this is a really interesting thing. Never heard anything about this. Never heard anything, period. A permanent return. Love seeing this render. This is what I was talking about. So this is like the crew version that has just an enormous elevator system, enormous doors, payload bay. Still has the landing thrusters that we see. Has a little bit different landing leg render than the crew one, which is interesting. This crew one has a billion windows. This is like more of a skyscraper. This is the deluxe condominium version that I'm making up on the spot, obviously further along the line. But like I was saying, if you wanted to, it has the payload capacity to basically put 20 Apollo Ascent modules on this as payload and deliver those directly to the surface as backups. Pretty wild. I think 2 would suffice. I don't know if we need 20. We're almost done here, guys, and then we'll take a few questions, and then I'm going to get out of here. NASA selected Starship in 2021 to serve as the lander for the Artemis 3 mission and return humans to the moon for the first time since Apollo. That selection was made through fair and open competition, which determined that SpaceX's bid utilizing Starship had the highest technical and management ratings while being the lowest cost by a wide margin. This was followed by a second selection to serve as the lander for Artemis 4, as the second selection to serve as lander for Artemis 4, moving beyond initial demonstrations to lay the groundwork that will ensure that humanity's return to the moon is permanent. Starship continues to simultaneously be the fastest path to returning humans to the surface of the moon and a core reminder of the Artemis program's goal to establish a permanent, sustainable presence on the lunar surface. SpaceX shares the goal of returning to the moon as expeditiously as possible, approaching the mission with the same I don't even know. See, this is why I don't read. And commitment that returned human spaceflight capabilities to America under NASA's Commercial Crew Program. I don't even know. Since the contract was awarded, we have been consistently responsive to NASA as requirements for Artemis 3 have changed and have shared ideas on how to simplify. Okay, no, this is a big one. This is a really, really big one. Since this contract was awarded, we have been consistently responsive to NASA as requirements for Artemis 3 have changed and have shared ideas on how to simplify the mission to align with national priorities, in other words, beat China. In response to the latest calls, we've shared and are formally assessing a simplified mission architecture and concept of operations that we believe will result in a faster return to the moon while simultaneously improving crew safety. That's big. What does that mean? Are they literally developing a different system? This is one of those things that I am talking about kind of in my video here, where I go over kind of alternative Starship HLS versions with turbo pumps or with all pressure fed, the entire thing, drop tanks, everything. I go into that a lot in this video. So I've been thinking about this for a while. I was maybe critical of SpaceX's original envisionment because it's actually really inefficient. They only really need those Raptor engines, especially all of the Raptor engines, and about 20 to 30 tons of just dry tankage to be able to do the translunar injection. After that, that's no longer necessary. So you're carrying around 30 tons of dry mass, 30 to 40 tons of dry mass for absolutely nothing. I've been critical of that, and maybe some of that has to do, not me being critical, but maybe some of these same factors are the things they're trying to consider. Can we make like a stubby Starship? We will see what that actually means, but I thought that was fascinating. Last paragraph, and then I'll answer a few questions. NASA's Artemis program was born out of a visionary goal to truly explore the moon and place the first footprints on Mars. Not to repeat the accomplishments of Apollo, not to be another entry in the long list of short-lived exploration initiatives, but to be the opportunity to finally build a sustainable presence on another planet. SpaceX was founded to make life multiplanetary, and Starship has been designed from the very beginning to enable the exploration of other worlds. With it and alongside NASA, we look forward to inspiring all of humanity as that first permanent foothold is placed among the stars. That gets me excited. That's why this was a big update, because there's actually this whole section was incredible. These renders are great. we learned a lot from this. So I think now maybe it's time to answer some of your questions. Sorry that I basically just went on my voice is sore already just from talking for so long. Hopefully that's what you guys want as a little update here, just to be able to be read to and answer some of your questions. So let's talk about some of the stuff here. Let's see. So from this person, I can't quite read your username. Are those landing thrusters in the black ring at the top? Yes. So the landing thrusters are exactly what you said, the black ring at the top. They appear to be in packs of 3, and it appears to probably be about 6 packs of 3, so 18-ish thrusters. I might be off by a little bit, but yeah, those are likely, we don't know for sure, but those are very likely pressure fed and still likely going to be methalox. I would prefer, if they were to make, they're talking about crew safety in a simple version, I would kind of love if they just used Super Dracos and used hypergolics for these first missions, because they're reliable, storable. I know it's kind of outside of the ethos of Starship, but if you could just refuel those and cut off a bunch of dry mass, you could do the entire mission using storable propellants. And the safety margin or factor of the ignition of hypergols is always a bonus to me. So that is that question. So speaking on that, from James Hardy, thank you so much for your super chat there. Have we heard any info about the landing engines? No, they still were quiet in this update in regards to the landing engines. So I don't know if we're going to see anything about that in particular, about the actual engines and how they're different. But like I said, I'm pretty sure they're pressure fed. I'm pretty sure they're still using methalox. And I'm also pretty sure that they are, pressure fed methalox. Yeah. So we'll see if any of that changes, but that's what we know of so far. This is not too busy. This isn't quite as on topic per se about this. Is there any reason why Starship cannot be slightly larger and wider, assuming it can still be caught? Well, the main thing is right now they have the production facilities set up for 9 meters. They have the transport for 9 meters. They have the ground support for 9 meters. They have the orbital launch ring for 9 meters. Everything is set up for 9 meters. It's already, in my opinion, overkill. I would have loved to see, I don't think it matters in the long run. But like in my head, just as a simpleton, I kind of think it'd be fun to have seen like a 7-meter version where you just basically cut out the outer ring of Starship and you have it be, the 10 middle and then 3 center engines for 13 engines on a Starship. I thought that would have been a nice introduction into this platform, and then expand out to 9. But I think the next one will be eventually, there's no reason we won't see them do like a 12-meter wide Starship, because the easiest way to increase performance of this isn't to do strap 3 of them together like Falcon Heavy, but it's just literally make new manufacturing lines, make a new launch pad and add another ring of engines around the outside, and get to 45 or 50 Raptors or whatever it is, and increase your payload capacity a lot. Let's see. This is it is mentioned in the document they are planning to build Starship facilities in California, I believe. Have we heard of those plans before? And if so, have we seen the progress? So I think they're literally talking about, how they built, Dragon was built at Hawthorne. I think it's just utilizing Hawthorne to build some of the components for Starship. I don't think they're planning to build like another Star Factory or like a major, Mega Bay or Giga Bay or whatever. I think this is just talking about that they're building some of the components for Starship. They did mention like facilities, Starship facilities, but I think it just means of course they're building some of the systems in California. Just to mention it, because I think this whole article is probably mostly politically driven to remind people that they are spread throughout the United States, et cetera, et cetera, et cetera. Let's see. This is Borg Terraformers. Thank you for your super chat. That is 100% true. Starship and SpaceX is betting 100% on orbital refueling, unlocking all of these capabilities. It's an insanely heavy vehicle. It's insanely big. It's so much bigger than any other vehicle that's ever flown, period. I mean, bigger than even any airplane that's ever flown, period, is how big all of the vehicle and the mass of Starship. I mean, it's just beyond anything we've ever seen before. All that dry mass doesn't make any sense to take it on deep space missions without being able to refuel in space. They are betting the entire house on refueling on orbit. And if that doesn't work out, the good thing is you could still like expend the upper stage and build stripped down, lunar landers and stuff like that, and payloads and deep space probes, et cetera, and use an expendable upper stage architecture. It's easier to go that way. Like say, oh, we can't figure this refueling out. Let's just start expending stuff and we'll just do it more halfway conventionally than it is to go, hey, we've expended stuff, but we really could do reusability and start refueling. That would be really nice. So they're at least trying the harder way. If in 5 years they're not where they're at with it, they could always pivot, at least in my opinion. But Mr. Sour Community, we did talk about this here. They mentioned, this is the first kind of mentionings of a depot power module demonstration testing prototype electrical power generation and distribution systems planned to be used on the propellant depot variant of Starship. So I think that's specifically, you need power generation to be able to do boil off prevention. So I think that's what that is in regards to. Let's see. Woodford, is Starship, I think you're referring to the HLS version, is it capable of returning to LEO? No. At least not by any of the Delta V numbers that I've ran. Again, I've got them all right here. And there's no thermal considerations. You don't have a heat shield. You don't have flaps. You don't have the aerodynamic features to be able to bring this back and do aero braking into Earth's atmosphere. Now, the good thing is the reality is if you had infinite time and didn't have to worry about boil off or anything, you could do very slow, like multi-orbit aero captures and stay within the limits of the structure itself. But that's not what they're going to do. They need to be able to refuel this vehicle in lunar orbit, and specifically in case of the Artemis program in near rectilinear halo orbit. But it actually benefit from being able to refuel in a lower orbit than an RHO. But hopefully... let's see. So I think that's basically it. I see a lot of other just kind of thanks and super chats from everyone. I'll answer one more question here, and then I'm just going to wrap out. And this is just going to be a fun little stream that hopefully you learn something by. What about leaving the surface? Will Raptors be used or the landing thrusters? So it'll be the reverse process. So they'll likely use the thrusters to ascend until it gets to a safe altitude to be able to light up Raptor engines. And they'll probably stagger the Raptor engine ignition so that they minimize, again, disturbing the regolith and making some kind of giant crater. So I think that's pretty much it. Thank you guys so much for tuning in with me. I hope this was kind of everything answered. And if you missed the beginning of this live stream, I try to keep it as succinct as possible so you can just go back and listen. But yeah, remember, this is the thing that I'm working on now. I have 2 other videos coming out that I'll teach you about in a little bit. And meanwhile, don't forget, get your tickets for Astro Awards, January 17th and 18th in Austin, Texas. We are over half sold out of our top VIP package and about half sold out of our Orbital, our other package, which has like lounge access and meet and greet opportunities and the big party and all those fun stuff. So if you want to join us and a bunch of people like Scott Manley and Joe Bernard and Zyla Foxlin and a lot of cool other people that will be receiving awards, head on over to astrooawards.live or also just everydayastronaut.com. You'll find a link for it. But astrooawards.live, January 17th and 18th. Hopefully we'll see you there. Last year was incredible, and this year is going to be even bigger and better with even more panels and more guests and more excitement. So really looking forward to that. Been working really hard on that too in the background. So that's pretty much it, guys. Thank you so much for hanging out, and hopefully this scratches your Starship HLS itch. I know it did some good scratching for me, and it's good timing for me with this other video I'm working on with the Artemis program and all the kind of alternative solutions or ideas. running all the numbers and all that. So it helps me kind of keep in mind of where we're actually at. So, well, that's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people, including you. Bye, everybody.